Have you ever imagined what it would be like to stand on the rusted surface of Mars and peer out into the vast nothingness surrounding you? It's a peaceful scene, with flat, dusty landscapes stretching out into the distance and a faint wind whistle as your only companion. But don't be fooled, because this red planet has a hidden secret brewing just beyond the horizon. A towering wall of dust and sand is about to unleash its fury, and you won't believe how massive it will become. This isn't your typical Earth dust storm, it's about to swallow up the entire planet. How does this happen, and just how dangerous is it? Join us for a journey to unveil the utterly unusual side of Mars, and stay tuned until the end to find out. What causes this superstorm to rise on the surface of Mars? Mars, the red planet, is known for its all-enveloping superstorms that occur every 3 Martian years, equivalent to about 5.5 Earth years. These storms are characterized by choking dust that can block out light for weeks or even months, posing a significant challenge to any technology we deploy on the planet. If humans ever want to establish a permanent presence on Mars, these storms will be a massive hurdle we must overcome. Unfortunately, we still don't know much about the origins of these storms. While Mars is now a barren and arid planet, it used to have a thick atmosphere that could support the existence of water. However, over billions of years, Mars's atmosphere gradually bled away, leaving the planet with an atmospheric volume of less than 1% that of Earth. The dust storms on Mars are not a recent phenomenon, and their origins are still shrouded in mystery. Although the exact causes of these superstorms are not yet fully understood, it is believed that Mars's temperature plays a crucial role. Despite having a high level of CO2, Mars has a thin atmosphere, making it challenging for the planet to retain heat. When the planet's surface starts to cool, there is no air to trap the escaping warmth, resulting in a significant drop in temperature. During the warmest part of the day on the Martian equator, you would feel 23 degrees Celsius at your feet, but 0 degrees Celsius at your head. The temperature swings on Mars are drastic, with temperatures ranging from a high of 27 degrees Celsius to a freezing low of minus 133 degrees Celsius at night. The temperature differential can lead to the formation of winds, creating different weather systems across the planet, making it a fascinating study for weather enthusiasts. Mars has a unique environment where dust plays an incredibly crucial role. The planet experiences enormous storms covering its entire surface, and these storms wouldn't occur without dust. The atmosphere on Mars is too thin to capture and transport heat effectively, but the Martian dust can do so. It's fascinating to see how such a small, often overlooked element can significantly impact the planet's weather patterns. The process of dust floating is quite mesmerizing. The process of Martian dust getting to the air is quite fascinating. It all starts with the formation of dust devils, which are quite common on Mars and can occur thousands of times yearly, typically during the Martian spring and summer. The sun's warm rays heat the ground, causing the air next to it to rise and draw cool air from the atmosphere to fill the void. These opposing winds create spirals of air that can span hundreds of meters wide and rise to 8.5 kilometers tall, although some are smaller. As they move across Mars's extensive deserts, they gather dust and propel it into the atmosphere, creating a veil of slightly darkened skies behind them. This phenomenon adds to the background dust suspended in Mars's atmosphere. Dust in Mars's atmosphere can come from various sources. One of the most visually stunning ways is through massive dust storms that engulf the planet. However, there are more common ways. Instead, the majority of the dust in the atmosphere is due to the influence of wind moving across the planet's dusty surface. This process, known as saltation, involves small particles being lifted and carried through the air. Despite their small size, these particles have a high degree of cohesion due to their electrostatic properties, which cause them to stick together like packing nuts. Consequently, some momentum is required to get them moving and airborne. It's captivating how the wind behaves differently with sand particles of different sizes. Believe it or not, the larger particles are more prone to being swept away by wind gusts because they don't stick together as much. However, as these heavy grains get lifted off the ground, they come crashing back down, creating tiny impacts powerful enough to dislodge the lighter dust particles. Once these minuscule particles are airborne, they can stay aloft in the Martian atmosphere for weeks or even months thanks to the planet's low gravity. This is what sets the stage for massive dust storms to form. Dust particles are like tiny heat sponges, and they can soak up the sun's energy like nobody's business. It takes a little while to pick up steam and start wreaking havoc on the red planet. Imagine a scorching desert where the sun's rays are so intense that they heat the dust in the atmosphere like a radiator. It's as if the air is holding on to the heat for dear life and refusing to let it pass through to the ground below. But as the air gets warmer and warmer, something incredible happens. The warm air rises on a massive scale, pulling in wind from all sides and creating a powerful force that can't be stopped. The wind causes more dust to be thrown into the atmosphere, creating a mesmerizing display of swirling sand particles that can stretch as far as the eye can see. And just like that, a small dust devil has turned into a massive regional dust storm, an awe-inspiring force of nature that commands attention from all who witness it. Although a dust storm on Mars may sound terrifying, it's less dangerous than it seems. On a local scale, the wind speeds only reach a maximum of 97 kilometers per hour, only half the speed of hurricane winds on Earth. However, this is still considered misleading, since the atmosphere on Mars is so thin that even when the wind travels at high speeds, it would feel like little. It's comparable to the pushing power of a single person. Mars is a planet that has always had a special place in human imagination. However, despite its intriguing possibilities, the planet's harsh conditions pose a significant challenge for any human or robotic explorer. One of the most significant challenges that Martian explorers face is dust storms. While these storms may not be powerful enough to knock over spacecraft or break satellite dishes, they still present a real danger. The electrostatic dust particles in these storms can stick to solar panels, which can be a significant problem for any Mars rover that relies on solar power. Over time, the accumulated dust can block the sunlight from reaching the rover's solar panels, making it impossible to function. The larger the dust storm, the more significant the problem becomes, and it's not uncommon for entire missions to be cut short due to dust storms on Mars. Doesn't Mars follow a perfectly circular orbit? The red planet is closest to the sun during the southern hemisphere's spring and summer, making it the warmest time of the year. However, what's even more fascinating is that this period is also when regional dust storms transform into superstorms the size of a continent. These storms are so massive that they can be seen from Earth. While they may merge due to proximity, scientists still need to understand the reasons behind their regularity. And these are just the continent-sized storms. Even larger planet-sized storms occur once every 3 Martian years. It's almost as if the dust cycle on the planet needs to be restocked, taking the same amount of time as 3 Martian years to do so. There's so much we still don't know about the red planet, but learning more about its mysterious weather patterns is exciting. Dust storms on Mars can last for weeks and profoundly impact the work of visiting scientists. To measure the availability of sunlight, they use aerosol optical depth, or AOD, to determine how much sunlight is absorbed or reflected by pollutants in the air. On Mars, the AOD is usually around 0.5. For context, rovers like Opportunity or Lander Insight require an AOD of less than 2 to charge their onboard batteries. A thick fire on Earth has an AOD of 7, while planet-sized dust storms on Mars can reach an AOD of 9 to 11, nearly wholly blocking out light. In 2018, such a storm destroyed the Opportunity rover by swamping its solar panels and forcing it into hibernation mode. The rover's entire mechanism collapsed due to the sticky black clouds. These storms pose a serious threat to other rovers and can also damage communication systems. Unfortunately, there's nothing scientists can do to prevent these storms, and even satellites can be affected as the dust particles can block their orbits. Exploring Mars is a thrilling adventure, but the dust storms on the planet make it even more challenging. These storms can hinder our efforts to uncover the planet's mysteries and slow our progress. But as intrepid explorers, we won't let anything stop us. We will continue to push the boundaries of space exploration and find innovative ways to overcome the obstacles posed by dust storms. With each challenge we face, we become more determined to uncover the secrets of the red planet and expand our knowledge of the universe. We hope you enjoyed this video. Please be sure to share your thoughts down below. And don't forget to subscribe to our channel for weekly space updates. See you next time.